Hello, everyone, and welcome to this workshop on optimizing generative AI and large language models on Intel Gaudi AI accelerators for enhanced performance. I'm Mohit Pujari. I'm an applications engineer with Intel. And in this workshop, we're going to have a look at how to access these AI models and how to run them on the Gaudi 2 processors. So I'll be doing a live example with a Jupyter notebook, and I'll be showing you how to do text to image and also large language model generative text inference. But before that, we'll have a look at the AI chipset and the software stack that comes with it. So here's the Gaudi 2 AI processor from Intel. As you can see, this is a single card shown in the image right now. You can have 8 of these cards running together in one server. Each of these cards comes with 96 GB of onboard memory, high bandwidth memory. It's built with 7 nanometer process technology. It's got 48 MB of static RAM and also 24 tensor processing cores with a couple of matrix multiplication engines built in. This card has been designed keeping in mind AI acceleration at scale. So you can have multiple of these running together and multiple servers having multiple such cards running all together for your AI workloads. Now let's look at the software stack. This is the Synapse AI software suite that runs on the Gaudi 2 AI accelerator. It's a shared software stack for training and inference both. You use the same code for running training and inference. This is fully integrated with PyTorch and TensorFlow. We support both frameworks. It's optimized for deep learning with minimal code changes. We have a rich library of kernels which are performance optimized for this AI chipset. And we have a very big artifactory of PyTorch and TensorFlow Docker images, which are ready to download and good to go. You can just download these images and then run your AI accelerator models on top of them. Now let's look at what is generative AI. So generative AI is a subset of AI that leverages some machine learning techniques to generate new and novel content. It does this by using algorithms to process data, and then it recognizes some patterns in that data, and it learns to mimic those patterns and uses those patterns to generate new data. So that's what generative AI is all about. And here now we'll go through a couple examples. So the first example we're going to look at is this one. It's the stable diffusion example. This is basically text to image generation. And I have a Jupyter notebook running, ready for this task. So you can find this Jupyter notebook on the Habana AI GitHub as well. And I'll show you right now how we go about running this notebook and getting a text to image generation. So the first step here is just setting up the basic code base. We've already done that. We're going to go to the current working directory, set the environment variables, and also install the requirements. This has all already been done. Here I'm downloading the weights, the checkpoint for the model. This has already been done as well. Now, this is an important step. We need to enter the input prompt for the model. So let's pick a prompt, horses running in unison on a beach. Now, here is the script that we are using to run this. We have just taken our input prompt and we're going to feed this script here. It's called the text to image.py script, and it has a few different settings that we are playing around with. So now I'm running the script. It has loaded the prompt. It's going to take a minute or two to generate the images. We have one sample image, and we are going through 3 iterations of those. Each sample has the size of 12 by 512, and we are using HPU graphs for inference. So let's see how that goes. Now you can see with this line, you know that the workload has been loaded on your AI chipset. It's going to start churning the data very soon. The model is going to load on your card, and it's going to give us an output with this input prompt. Some images of horses running in unison on a beach. All right, so that was it. Now we should look at this by loading these images that have just been generated. There you go. There's the first image, second image, and the third image. Very nice looking realistic images from a simple input text prompt. Intel Gaudi supports various AI models across different domains, including computer vision, natural language processing, diffusion, and even audio models. You can find many of these on the Intel GitHub website. There's support for 40 plus models available on the Intel GitHub website. Other than that, we also support models from Hugging Face. You can use Hugging Face libraries and source code to run these models on the Gaudi 2 AI accelerator. And the third way you can run models is you bring your own model, open source architectures, which are already running on other hardware architectures. You can then migrate those to Gaudi 2 AI accelerators using the migration toolkits. Also, we have a lot of developer related materials. We have these major websites, 4 major websites. First one being developer.havana.ai, where you can find tutorials, events, performance data, and sort of that. You have other documentation on Docs website. You can find how to set up and install, do migration of the scripts, and also basic user guides. We also have a service desk for our customers. If you have any pending questions, and if you have any how-to requirements, we can help you with those here. And of course, we are fully supported on GitHub and Hugging Face. Okay, so now let's jump into the Llama 2 70 billion parameter models inference example. In this example, we are going to run this model to generate some text. And let's have a look at the command that I'm going to run now. So this example comes from the Hugging Face Optimum Habana library. It's part of the examples text generation folder. And here's the command. It should be there in the README. If you go to that website, you'll find it there. So this is my command. What I'm doing is I'm asking it to generate text with 256 new tokens, and I've chosen the Llama 2 70 billion parameter Hugging Face model. So it looks at that, and I'm using deep speed. So deep speed allows me to run this huge model across 8 cards, and it distributes the memory in a balanced manner. And that's why I'm able to run these without the memory running out on each of these cards. So it takes a couple of minutes to run. And at the end of this, you should see some fine text coming output from the output. We have given it an input prompt called as peace is the only way. That's the only input prompt I've given this model, and it is expected to give us a bunch of text based on that input prompt. So let's have a look. Now the checkpoints have loaded, and as you can see, this was my input, peace is the only way, and it's given me this paragraph of text of length 256 tokens as I expected it to. And also at the end of this task, here are the stats that are printed. It has some performance numbers and memory consumption numbers. And as you can see, the process has exited successfully across all the 8 cards. So that's why it's printed 8 times here. So that's the end of this example. Now, let's have a look at where you can find these Gaudi 2 cards, how you can access them. We have this developer cloud, and you can go to this website. It's called developer.habana.ai, Intel Developer Cloud. And here you can register yourself, and then there are steps laid out on how to get some cloud credits and sign in. And then eventually what you will get is something like this, an instance of the deep learning server. It has 8 Gaudi 2 cards with the Intel Xeon processors on board. So that was the end of this tutorial and workshop. Thank you for watching this, and good luck to you on your deep learning adventures.